So guys, we can start. Thanks a lot for your participation. We are happy to have you here in our roundtable about the digital twin. So as I've said, we will have 50 minutes all in all, and we will take 40 minutes for discussion, and we'll leave 10 minutes for Q&A. I suggest we start with a short introduction of each one of you, and we'll take it from there, please. So I suggest, Colin, you will start, Richard, Rav, and Artem.
Okay, good morning, good afternoon, good evening, all. My name is Colin Paris. I am Senior Vice President and Chief Technology Officer at GE Digital. In terms of digital twin, we use it extensively here at GE. We have a $300 billion services backlog, and that services backlog is used to service some of the biggest assets in the world that we have, whether they be jet engines or gas turbines. The twins are vital for us to understand the state of those turbines, and by that, we can then keep our commitments to performance, to availability, to reliability. Delighted to be here.
Richard? You're supposed to unmute yourself.
Yeah, that's better.
Yeah.
I'm Richard Stoley. I'm Chairman and CEO of the Object Management Group. But more relevant to today's discussion, I'm Executive Director of the Digital Twin Consortium and serve on the DTC's steering committee with Colin Paris, meeting today, in fact. And we have
We lost you, Richard, so we will wait until you rejoin. Rav, we will move to you and we'll get back to Richard again.
Okay. Hi everyone. Good morning, good afternoon. My name is Rav Lawana. I work for Schneider Electric. I lead the strategy for the Machine Solutions division, which is part of our industry business. And a little bit opposite to Colin, we're in the machine automation business, so we supply the machinery into OEMs, robotics, automation systems, and the like. And we're looking at how digital twins can enable our OEMs to be more productive, more sustainable, more efficient, and more innovative. So a bit of an opposite end of the chain.
Thank you, Rav. Artem?
Sure. Hi, everyone. My name is Artem Kroupenev. I head strategy for Augury. And Augury is a leader in machine health driven by artificial intelligence. We work with some of the largest industrial manufacturing companies where our solutions keep tens of thousands of machines running and making sure that they perform at their best. What our solutions do is essentially identify very accurately when, how, and why machines would break down or underperform, and then prescribe the course of action to the technicians, operators, reliability engineers on exactly how to avoid those issues. Happy to be here and happy to talk about digital twin. Just one thing to add, there's a connection to digital twin for machine health is the same thing as it is for, I would say, for human health, right? In essence, it's an essential part of kind of making sure that machines operate, and an essential component of the wider view of kind of the digital twin for equipment and for systems.
Good. So thanks a lot. My name is Leo Backman. I'm co-founder of Halo Digital. We are working on the area of modeling of complex production processes, basically with the goal of building a navigation system for complex manufacturing like chemistry, biology, pharma, areas like that. So I'm really excited to lead this table. And the reason is that it's pretty rare event when you can, cover 20 years of a process and try to understand what happened during this 20 years. So basically almost 20 years ago, a US professor started to talk about the concept of digital twin and its potential impact on optimizing manufacturing. Mainly thinking on the idea of, a day will come and the data will be much more available and the computing power, all the regular stuff. And basically 20 years went by, a lot of conversations, a lot of forums. After a while, Richard decided that he has to build a consortium of digital twin, but something dramatic happened in the market. We are expecting huge growth, $35.8 billion of market worth around this digital twin. Hundreds of thousands of academic publications. So certainly during these 20 years, something real happened. Yet, as usual with big trends, it's a bit hard to transform the big statements to translate buzzwords like, amorphic things like digital twin into things which are much more fundamental, much more business oriented, much more, entry points for startups and things like that. So during the table, we will try to deal with all these elements and basically try to understand two things. One is, what is a digital twin? Each one look on it from his own perspective. So we'll try to deal with that. And later on, assuming that most of our audience are basically coming from the startup world, we will try to identify where are the opportunities for startups? Or in other words, what are the different entry points to this world? Because by the end of the day, we have factories, they are producing things, and we are trying to envision things that will happen within 3, 4, 5 years ahead. So how we are actually getting there? It's much easier to understand how a full digital world will look like than actually getting there, or what would be the steps. So this would be our subjects. And as an initial point, I would suggest that we'll cycle between the panelists and really try to understand what is a digital twin for you. And in terms of for you, I would really ask you to emphasize what actual market needs. What are the opportunities that this concept is touching, both short term and a bit longer term? And as a representative of the consortium and the person who's dealing with the definitions, I suggest we'll start with Richard and follow with Colin. Richard.
Can you hear me okay?
Absolutely.
So to finish what I was saying, besides the Object Management Group, one of the world's largest standards organizations, I'm executive director of the Digital Twin Consortium. Colin and I and several others are members of the steering committee and meeting later today. What's really interesting from the point of view of a startup is, although it costs up to $50,000 for members to join at this point, startups can join if they have zero revenue for $0 the first year of 3. So it's a great entry point to find out what's going on, where the opportunities are. And we think the opportunities are in healthcare, in defense and aerospace, manufacturing, natural resources, and in infrastructure, meaning construction infrastructure. This week, we're going to publish our definition of a digital twin, which is really just a nothing more than a electronic version of the real device or process, and synchronized with the real device or process, so that you can use that information for future predictive maintenance of the system. If you get it right, if you get interoperability and composability right, you can compose a large electronic device. For example, an airplane is made of landing gear, wings, fuselage, and so forth. I'd like to be able to take a digital twin of the empennage, a digital twin of the landing gear, digital twin of the fuselage, digital twin of the wings, and add them together. And today I can't do that because we lack interoperability and composability. That's what the consortium is trying to solve.
Great, thank you. Colin?
Okay, I'll follow on to what Richard said, because I think, in the consortium, we've laid out a really good way of thinking about the twin in a very structured manner. But when I boil it down to what I need, when I think about the manufacturing and the aerospace industry, I think of a twin as a model. Everybody knows models, right? Because this is what they live with. But a twin is a living, learning model. So it means that normally I build a model, and after I use that model, I discard it. I build it, I get the design right, I design the thing, I stop. How about if you keep the model alive? Continually feed this model, and this model reflects the exact state of the asset. That's living. Then how about learning? How about if I look at other models out there of the fleet and I learn from them? How about if I learn from simulations? So now I have this living, learning model of the asset. And once I have that, now I can apply it to actual business value. I take that and I try to determine some things. So for instance, I have these jet engines out there, as Richard mentions. I have a certain performance guarantee. They've asked me to make sure that the fuel efficiency is at this level. That's the commitment I made to the customer. Well, I can look at the twin, and the twin can tell me when is the fuel efficiency dropping, either because of the fact that I have wear and tear on the machinery or it's not being operated correctly. And then I can actually then inform, the customer, here's what you need to do to increase the fuel availability. I can look and I can see when should I bring that asset in to get that asset fixed. If I know that, then I can build those parts way in advance, because what I don't want is to stockpile a ton of parts to have a huge inventory, or wait until the asset comes in there and then say I need the part. These parts have a 6-month lead time. So the twin is being used, and at least in our industry with aerospace, in which it's trying to actually meet the performance guarantees and to get us in a position where when we have to maintain these assets, we do so at the lowest cost. And that's what you'll see we have the same thing in the oil and gas industry. We have the same thing that we see in the power gen industry. So that's what a twin to me is: living, learning models that can address the business needs in a way that I can save costs and increase customer sat.
Great, thank you. Rav?
I think both Richard and Colin, being in the forum, have expressed what a digital twin is very, very well, very eloquently. What I would like to just add to that is how, when we look at the machine automation or discrete manufacturing, and what that means. So bringing it right down to a machine, what our customers are looking for when they're looking for a solution, a digital solution, they look for 3 areas where they're going to be more productive. The first area is they want to simulate, similar to what Colin said earlier, they want to simulate their machine design for maintenance, for performance measurement, but also for design to try and you imagine a production line of a machine making this kind of widget. When they're selling those machines to end users, the widgets might change a bit, or there might be different configurations, different bottles or different cartons, and they want to be able to simulate those to see how their machine performs with those different conditions, and then prove to the end user that that's a useful machine, and use it even at the simulation stage as a sales tool or as a proof of concept tool. Once it moves from the simulation phase, the next phase of a digital twin for our business is to do the virtual commissioning of the machine. So designing the code or the system performance, or how the robot moves around the machine, how each part deforms and forms, doing all of that virtual commissioning digitally. So by the time you've built the physical machine, you're able to, in the best case, just transfer the code over, and the machine just runs, and then you do a little bit of tweaking, and then you send it out. So saving all of that time in the commissioning stage. And finally, once the machine ends up at the end factory or the end plant, it's all about then the operation and the maintenance. So the training of the operators in the digital world. So before the machine arrives, they're able to be familiar with the controls, and having as a real life. Also for the process optimization, for the maintenance, running 1 million cycles or 2 million cycles of the machine to know which part will break first, or where the bottlenecks could be when you're retrofitting and upgrading a plant. So in discrete manufacturing, where Schneider, or Machine Solutions in Schneider operates, is really about simulation, virtual commissioning, and then operation and maintenance. That's it. And not repeating anything I think Richard and Colin said very eloquently.
Thank you. Artem.
Sure. So I think it was incredibly well said. I can bring more of a kind of a foundational use case or practitioner's view of this, or the aspect of digital twin. We're deployed on existing assets primarily. I'm working with some OEMs on new assets, new machines. that will come out into the field in the future. But primarily existing assets where we retrofit them with sensors, and those sensors are then sending data, and then that's enabled by AI. And that's where I really like the definition of a living learning model, because that's exactly what happens, right? So for a wide range of rotating assets, primarily in kind of process continuous manufacturing, whether it's motors or pumps or extruders or any type of rotating equipment, those models already have been created, and they are definitely living learning. So the way the machine is monitored, the way it's diagnosed, and you provide prescriptive, actionable insights, exactly what's happening within that machine, and then the way the asset strategy is planned, moving from a compliance time-based maintenance or reliability strategy to an insight-based maintenance reliability strategy, and then the way the technician acts upon those recommendations, and that activity is captured back into the AI to learn in that model. So for individual machines, there's a continuous learning improvement modeling process that informs other activities around operations, around maintenance schedules, around procurement, inventory, and others. And it's also tied directly to the business side, where by avoiding downtime, by reducing costs, we're actually increasing capacity for manufacturing. So there's a real implication. But what I can add to that definition is that it's not just a learning, living learning model for the discrete machine in itself. It also learns from other similar machines, right? So it's kind of connected, and so we have many thousands, tens of thousands of machines in the database that are continuously learning from each other. So the AI kind of sees one type of pump here, and then somewhere else in the world, that pump informs the diagnostics for another piece of equipment. And so I would add to the digital twin concept that networked learning concept that we have as part of our, as part of our solution, and hopefully others around machine health as well.
So, thank you.
Before we move on, I think it's really important to point out what I said, what everyone said, actually, that it's not just a model. We believe in modeling. OMG, in fact, owns UML and SysML. It's the model connected to the real device or the real process in real time, so that you can learn the living and learning part that Colin talked about, that Artem talked about, and Rod talked about is very important.
Cool. So I basically a follow-up question. I mean, you all were very clear about, I think, two things. One, that manufacturing environments, in a broader sense, is a highly complex system, that additional technologies, beyond human capacities could be dramatically helpful. The capacity to learn from different systems, and the capacity to be able to see things that people cannot see, second, third order degrees relationship, things like that. So on this, the need is pretty clear. And as well, you were all pretty well aligned regarding what is a digital twin. So I think I have a very simple question to you. Why did it take 20 years? I mean, 20 years passed by, and the impact is still just starting to be seen. Where are the problems? If it is so clear and the need is so obvious, what are the challenges in the implementation? Richard, you started to say, I think you have perspectives, and Colin, each one of you has a perspective from his own angle. Let's talk about the problems. Richard, your turn. You are on mute again. You should unmute yourself. Richard? Cool.
That's better. I'll stop muting myself, because I can mute myself, but I can't unmute myself. The problem is, I would argue that we've done this for a long time, just didn't call it digital twins. When I was designing VLSI chips in 1980, we always made an electronic version of the chip before we made any real version of the chip, because it was very expensive to fab the chip. So in a sense, we were doing a modeling simulation of the chip, and in fact, we took a description of the chip, the inputs, outputs, and the circuit, and the circuits provided by the chip, and fed it to a compiler, and a compiler generated the entire chip. And maybe we tweaked it afterwards, maybe we didn't. So we've done it for a very long time. What makes it difficult? The reason we're not seeing digital twins is that you can buy from General Electric, for example, a jet engine, or you can rent a jet engine from them, powered by the hour. But you can't get a digital twin of that jet engine, and that is going to change. Where it's possible to buy or lease devices or processes from large companies, you will be able to get a digital twin of that process or device.
Thank you. Colin, where are the problems?
Well, the first one I would think about is data. So we all think, we've had this for 20 years. Have we had the data that would allow us to do that? So if you say, well, yes, we capture all this data, in fact, we don't, right? So when you look at it very clearly, it's very hard to get the data. I go into the manufacturing plants, and when I see it, they have 15 different systems. These systems all have different formats. The data is missing because people didn't put the data in. The data is inconsistent. We have the same set of data in 3 places. The data is incomplete. So getting the data I need to actually build that living model, it's easy to do it in the lab in the design phase because it's just engineering, right? One focus area. The minute this asset goes out, there are people who make changes in different parts. There are ways it's operated. All of that data, bringing that data together is very hard. Nobody actually took the time and space to not only get the data, but you got to fuse the data together. So data is a major issue. Even right now, when I go have that discussion, there are countries that don't want you to see their data. There are companies that don't want to give you access to the data. There are companies that actually did mergers in which when you merge, there are 2 different ERPs, 4 different MESs. The data itself is very hard. The second part is the process. In my world, things only translate when you can make money out of them, right? So when I look at how we make money, for instance, in GE, the bulk of the money is made in the servicing of the asset. Why? Because a jet engine lasts 40 years, a steam turbine lasts 30 years. So when you sell the asset, you make a little bit of money. When you service the asset, you make a lot of money. So now what you have to do is when you get the digital twin and it gives you an insight, you actually have to use that insight to change something inside your service process. To do that effectively, you need definitely business process transformation. I have to redo my entire service process where humans are not making decisions. What we have in many cases is humans. For instance, we have a number of assets coming in, and a human will sit there and say things like, I think we'll need 400 of these blade sets in the next 2 years. Why would the human say that? Well, historically, and I have a gut feel. That's wrong, absolutely wrong. You need to collect the data, actually put it in the process, actually understand how much these things cost, how long they actually take to deliver. It is a real data intensive job to do that. And so you have to change your business process to reflect that. And when you do, that's when you see the value coming up. So now what we're doing is we're gathering the data at a level we've never gathered before, right? Because we have a cheaper, easier way to do it. Then we also are doing the business process transformation. If you look back in the consumer space, the people who use AI, for instance, you embed AI in a process like an Amazon process, they change the business process. The way that you shop, they literally changed it and embedded the AI and data to make it work. Google changed the way you do ads and embedded the AI to make those ads be more efficient. In manufacturing, where we are now with services, we literally have to change the service process to embed the AI in. So I think it's data, and I think it's business process from my point of view.
Great, thank you. Rob.
Yeah, Colin and Richard, they make the very clear points. So data being the evolution of the data over the period. And also what Colin said, which was very valid, that maybe we've always done it, and I think I can build on that, because if I look at the manufacturing world, I've been in this world 20 years. I joined 20 years ago into automation and into Schneider, and I realized that we spent the last 20 years in this environment of having a closed system. So this OT world and this IT world, I think it's called. So the operating technology and the information technology was always kept separate. So like Richard said, probably in the IT world, maybe in chip design, maybe in the CAD rooms, or maybe in the mathematical models of the end consumer, they were already using some modeling, some simulation, some data analysis. But when it came to the machine, we were in the OT world, we were in an operating world. So we would have our own system, our own way of doing things, and we would optimize as much. Schneider gets paid when our machines or our solutions or our robots or our automation performs at the maximum level. At that maximum level, we strip out everything. We say, right, our CPUs only care about movements, and our sensors must react as fast as possible to the input. And that's what made us successful. What that did, in what Colin said very well, was that stripped out all of the data. Nothing was open, nothing would work with each other. And I think what's changed, so what's changed in the last 5 years when we saw this growth, there's been a big exponential growth in computing power. Now the 3-core, the 4th core, the 5th core CPU, or more probably. There's so many cores and so much computing power available at the edge, at the level of the machine, that you're able to now process data in your IT and your OT at the same time. So we're now able to process that data and manage it, and we start to see these insights. And then you have the convergence of this IT and OT world, which allows you then to say, okay, well, you know what, we kind of know in the simulation how this model should work. How does it work in reality? Can we plug in some points together and see how that reality is? Oh, okay, there is a difference, and let's optimize that difference. So I think, building on what the colleague said, it's the convergence of IT and OT which has made the big difference. And that's been driven by the excess of computer power that we have now. Computing power at the edge.
So basically, thank you. So basically, if I'm trying to summarize, what you are saying is that, manufacturing environments designed to be safe, designed to be reliable, designed to be effective, they basically never designed to be digital. And this lack of design has an impact on the lack of critical infrastructure that we are calling data, lack of culture, if you want, lack of business processes, which basically make it so complex to move this digital transformation ahead. Artem, for the last 5 years, you are taking part in one of the most successful startups in this area. You're implementing huge amount of systems all around the world. What has been changed? I mean, you are not coming from manufacturing. If you can, maybe it's a bit intimate question, but initial conversations that you had with customers 5 years ago, you came from the high-tech industry and you met not high-tech industry, or not exactly what you used to meet. What have been changed during these 5 years?
So I think I can probably offer a slightly different perspective here, because the technological issues that have been voiced here are very true, right? There's a lot of infrastructure has been lagging. A lot of our customers still today are data rich and insight poor, right? And that's very true. But I think what has been lacking for a variety of reasons is essentially companies that were able to break through that and turn that lack of kind of technology into an advantage, and then really translate that into real world business results. So we've had very few use cases that were very clearly providing value around that space at a very large scale, right? And I think that Augury is part of that kind of movement to create some of those use cases. If I were to create an analogy to kind of the human world, right? Not the machine space, is that quantified self, or if you will, kind of the human digital twin has been around. That concept has been around for 20 years as well. But only recently have you had real advancements where health came to the forefront, because there are technologies today that can actually prevent and identify early stage cancer or cardiac, heart issues or other types of illnesses that are very real, right, and provide real results for people. And the same goes to the athletic performance, mental health, and other aspects of kind of the human health and performance. The same thing goes for machines, right, and for systems. We've had really great concepts, but very few concrete examples where there's tangible, immediate value at a very large scale. And I think that today, when speaking to customers 5 years ago, we sort of felt like being, I would say, in the 1910, right? Or if you can imagine 1905, where there's a lot of different people who are selling the concept of a car. And people have steam engine cars, and people have cars that have they're electrified and then internal combustion. But what you really need to help the customers understand is not that your car is better, but rather that they need a car in the first place and what it actually is, right? So this is where we started, 5 or 6 years ago. Today, it's a very different story because there's a really tangible body of evidence that millions of dollars are saved, and machines and processes are significantly improved within a very short amount of time. It was really a technical issue that had to be solved, technological issue that had to be solved, how to get the right data at scale, how to create the AI that can actually diagnose this with a very high level of accuracy. But today, the machine health use case, we can say we actually guarantee our results, right? It's at a high enough level of accuracy, at a high enough tangible value to customers that we can say if a machine fails on our watch, we will pay to replace it. And that shows the maturity and confidence in this use case. There are a number of other use cases, right? Foundational use cases around digital twin that will actually help accelerate it significantly, like machine health. And the more of those use cases we actually look at closely and deploy, the faster we can accelerate the adoption of digital twin as a whole, I believe, right? So for me, it stems from very tangible business results, identifying the clear use cases, and then utilizing platforms like a consortium or other means of standardization in order to be able to accelerate the adoption of this trend.
Great, thank you. So I think next topic, we have on the panel, and as I can see also in the audience, people who both driving, if not inventing, this automation industry and manufacturing in general in the last 20, 30 years. And I think usually when you are looking on paradigm shifts and a massive changing, and Artem, you referred to that actually, I mean, you are starting with small pieces. You are starting with small use cases, small value propositions that you can prove, and then you are moving forward. You're trying to do more. And the whole idea with advanced analytics and digital twins or all these things is actually adding more and more and more layers. I mean, Richard talked about it, Colin referred to that, Rav as well. And then comes the biggest question, I think, at least to this forum, is how does exactly this play business-wise and technology-wise has been organized? Because it's always a very big question for startups. We are looking like 3, 4, 5 years ahead. And the biggest question is, I'm coming as a newcomer to this world of manufacturing. There are many big companies. There are companies who are coming from the PLM perspective, companies that are coming from automation, companies that are coming from more data management systems, machine vendors, and so on and so forth. It's pretty why everyone wants to move beyond selling machines to deeper services, capacities, and things like that. And then one of the biggest questions, which I think dramatically associated to what is a digital twin, is what is a digital twin for startups? Okay, so you all represent, not all, but you are, at least Colin and Rav, you're representing the biggest companies in this world, and you are looking on this landscape. I think your feedback regarding where is the startup play versus where is let's call it the big organizations, the more established organizations play would be a very, very important angle, because a lot of things are coming from your own capacities, from your own current assets, and it's a bit hard to imagine how a company can come and just fully disrupt this world, mainly because of the fact that by the end of the day, most of the factories are already there, operating, running your systems. So as an entry point, what are the main trends that you at least identify as the trends which are open and beneficial to startups to focus on versus trends which are more relevant to, the big companies, the Rockwells of the world, the Schneider Electric, the Siemens, etc. Colin, please.
So I'll go back to the discussion we had before about the process and the data. So what if I was in a startup right now, I'm thinking about what's different. Yes, there are big companies and big companies are running things, but big companies tend to optimize for one or two scenarios because that's how they actually make money. However, right now in the world is getting very dynamic. So when I look at what's happening right now in the energy space I'm in, we have situations in which before I would build a gas turbine that runs all the time. Now with renewable sources, that gas turbine doesn't run all the time because people are putting on new renewable sources when the sun doesn't shine or the wind doesn't blow. Then you actually make that gas turbine run. So now all of the data you had about a stable gas turbine is not true because these things are fluctuating. I look in parts of manufacturing plants. We work with smelters. And before, again, the smelter process, you want it to be one process and you run that one process and that's how you optimize. But given the changes in the type of ore that's coming from different parts of the world right now, and the different rules that are being imposed in terms, of cleanliness of the environment, that's becoming very dynamic as well. So you see smelter companies saying, a lot of data I had before, a lot of the techniques I had before aren't working because of the changing market. So I would look for places where there's a lot of dynamics coming in and go in and help them understand their process. Because I've seen in those worlds where a lot of new companies are showing up and saying, well, if my old data doesn't work and my old expertise doesn't work, I'm now willing to try something different. Can I take data from multiple sources? Can I use AI systems, whatever you have, convoluted neural nets, any way you look at it, or a combination of the physics I knew before, historical data, and new data coming from different sources? And can I help you get a better process where I end up saving aluminum ore or saving the carbon that's in that process? Or in the energy process, where there's a lot of cycling, can I show you how to forecast when wind will drop, when the less solar will be there, and what do you do to optimize fuel economy that you have? So I would spend the time and learn the process itself, because the process is the key to the money. If you understood the process, then you could go into the company and say, if I get this process right, I'll save you X dollars. If you want to talk to senior execs, talk about how much dollars you're going to save first, then you go into the process. That's one angle. The second angle is data. Every company realizes there is gold data. Not all the data is created equal. In my world, the inspection data is most important. I have a twin. The twin tells me that this is the amount of failure you would expect. This is the length of a crack, so I would know, in the next year, the crack will grow this length, I need to replace the part. The real moment of truth is when I pull out that part and I measure that length of crack. There's a lot of data like that. That's called gold data, because that data tells you if your model is right. In many cases, we have humans looking at these cracks and measuring them by hand. Do you have computer vision systems could do that? Do you have other techniques? So there is data that is key. If you have techniques that you can go in and get that data at the right granularity for us, that would be huge. Because in many cases, these large companies don't know to get it. They have old processes where people measure things, where people size it up. To my shock, in some cases, when you're looking at the damage on a blade, there is a scale of 1 to 10, and a person says, I think it's an 8. Okay, what we find out is that if that person has been around for 4 years, that person would have set a 6. If they're around for 2 years, they'd have set a 5, right? It is so subjective based upon who you are. There could be ways of making that much more definitive. I'm even using systems right now where I can measure the pixels off of a photograph I take, and the pixelation level and how many pixels you have actually tells you the progression of the crack. So there are ways, I think, in the data space and in the process space, that's the place I would go given what I know.
I think what Colin said and what Artem said before pointed towards a real opportunity for startups everywhere, all over the world. And that is, in manufacturing, there are very specific use cases that we're going to be publishing this month or early next month. You should take a look at. I know a company, for example, that does predictive maintenance of tube manufacturing. Very, very specific. But outside of manufacturing, there are hundreds of cases, thousands, tens of thousands, hundreds of thousands of cases, opportunities in healthcare, like Artem said, in infrastructure construction, in natural resources, in lots of energy, like Colin said, and many other opportunities as well.
Good, thank you. Rav?
I think again, very, very good answers from my colleagues. As always, I like to build on the conversation because I think there's so much knowledge around this table, or this virtual table. It's important to make sure we build on each other and give the best answer. Colin mentioned the most important thing when Schneider looks at startups, and we're actively seeking startups. We're saying. I wake up in the morning saying I probably haven't invented what we need tomorrow yet, and we need to work with partners. So we're actively looking for partnerships and startups. And any of you can find me on LinkedIn, please feel free to connect. But coming to the one of the key points that both Richard and Colin said is the business case. The first thing anyone pitching to Schneider should think about is the business case. You can't, I mean, technology is wonderful, ideas are great, but is there a business case behind it? Is there a value to that data? Is that data then chopped and changed and analyzed and manipulated, and it's worth something to somebody else? There has to be a business case. And I think that should be the first thing. Don't fall in love with the technology, but to define the business case of what this could be worth to someone. What does it replace? Does it replace manpower, save energy, reduce maintenance? But there should be a solid business case. But I'm going to take your question more to the core of what you said, Leo. You said, look, we're in the digital place. Schneider is under EcoStructure. We're reinventing the digital economy for manufacturing, and we're proud of what we're doing. But we have a huge install base. And I'll give you a real example of yesterday. I was with our R&D, and they're talking about, we've got to move our 2G modem to 4G. And I went, well, I mean, everyone's talking about 5G, guys. They go, yeah, but we have so much install base on GPRS. And they don't want to move to what, and this is our issue. The issue is we're big, and because we're big, we have to take care of not only our brand new customers, our new technologies. We have to take care of all our legacy. And some of that stuff was built on processors that Richard probably developed, it won't jump that fast. So we need startups to bring that innovation to us. To talk about, while we're talking about now connectivity and TSN networks, I'm sure somebody out there is inventing the next blockchain communication network, and that's what we want to see. And that when we bring that into our organization and offer that to our customers, that's how we innovate, and that's why we keep growing. So that's a short and long answer.
Good.
Business case and technology evolution is important. Sorry, Leo.
So we have another almost 5-7 minutes. Artem, you are from a startup. You are attacking the world from a specific angle. You are talking to a huge amount of customers on a daily basis. Where are the opportunities which has nothing to do with you? I mean, and if you would leave Augury, you would focus on, or you suggest others to do it?
So I think what was said here is absolutely right. I would sum it up. For a startup, you have to focus, right? So when you think about startups versus larger enterprises have the luxury of time and running very large portfolios of things that might fail, whereas a startup doesn't have that same level of luxury, and therefore focus on domain expertise need to drive that. And if there's any advice to a startup, where to focus, whether on the technical side or business side, where you can solve a large horizontal technological problem, or you can think about it from a business perspective, absolutely focus on the business perspective. So that's what we've done at Augury, and most successful startups have done in this space, is really look at the business process and identify the critical problem you want to solve that is highest value for the customer, identify the technological reasons behind that problem, and then find a solution that solves for those, right? Or the other route you can take, if you want to be even more ambitious and disruptive, is to create a new business process. To look at the old one and say, well, technology fundamentally changes that whole process, and we're not plugging holes in that process. Rather, we're going to eventually change it so fundamentally that it will be replaced with something else. right? That's kind of the route that we're taking. And if you think about the business processes within the industrial manufacturing space, very simplistically, it breaks down to three parts. There's assets, there's operations, and then there's business, right? Or finance, right? Let's go that way. And the Industry 3.0 perspective on this is that those are separate parts that don't necessarily talk to each other and are based on lagging, compliance-based, time-based indicators, right? My asset maintenance book, right, it predicts what I need to do for the assets and tells me for the next 40 years. My operational schedule is based on something that's engineered into the process 20 years ago. And my finance is based at best on annual projections, right? But all that's going to change, right? Obviously, with digital twins, those three components are going to become part of one and same thing that is informed in real time, is modeled in real time. And we come from the asset space, right? Create a real source of truth, but also interact with quality and performance and the financials of those assets, kind of creating those connections towards the other parts of what our customers care about from a business process perspective. So if I were to analyze a business process in manufacturing or industry, I would look at the interrelations between assets and operations, operations and business, business and assets. And I think that within those spaces, those are the use cases that can really be benefited from AI, much better data, right? And applications that can replace whole sections of existing processes and drive them towards something that's based on insight, foresight, predictability. So I think that's how at the high level, that's where the opportunities lie, and really that's where what will accelerate the adoption of and kind of the digital transformation, moving into what's called Industry 4.0. It's those intersections and those critical use cases around those intersections.
Great. So first of all, thanks a lot. I think we were so clear that we have no answers from the audience, questions from the audience, or we were so precise that they just left everything and now they're building their pitches to execute, to pitch to the current investors in the forum. So I suggest that we can, each one of you will take another minute or two just to summarize. So Richard, should we start with you?
Sure. I mentioned something I haven't mentioned before, that the consortium is only 8 months old. And in those 7-8 months, we've put together something like 180 members. Over 100 of those are startups who pay nothing to participate the first year. So if you're a startup and trying to figure out where the use cases are, as Leo says, this is a great way to find out over the next year. It's a great way to join because no one is going to win in digital twins. You're going to have to work together to get composability and interoperability across the life cycle of a digital twin and across vertical markets of digital twins.
Great.
That's the opportunity.
By the way, we have one question from audience. Are you about to publish the report that you talk about of the use cases, or it will be open just for the consortium members?
It's a secret. No, I'm kidding. It will be. It was approved by the steering committee last week, and it will be openly published this week.
Good. Okay. Colin, closing remarks?
Hey, well, Leo, I want to thank you and the rest of the panelists here for an enlightening time. Thank you again for inviting me. I'll leave with two things. One, I'll reflect on what Richard said. I think it's a great idea to join something like a consortium. You don't need to learn or relearn everything other people have learned. So if you join something like the consortium, you have the ability to actually learn from them a lot quicker. The second thing I'd say is look for areas in which there are massive dynamics and changes for one reason. Humans, whenever they have a process that's working, if you want to change that, it's extremely hard. Whenever it's a very dynamic industry in which they're forced to change, either because of chaos or opportunity, you have a chance to bring a new idea in place whereby many people wouldn't have taken it before. Now they will because they have to. So look for these areas where there's a massive amount of churn or a massive need and go in there. But do it with partners. Join the consortium, do it with partners, and look for those areas. Thank you.
Thank you. Rob.
Of course, joining the consortium, I'm already signing myself up, Richard. So look for my application. I want to. I want the report. I think. I think the digital twin is the future of the industry. So to our audience, I think if you're working this space, you've already made, several good moves. And if you're targeting manufacturing, you're in a really a blue ocean of opportunity where you can define it. I would say, look, as a company operating in this space, and also looking for technologies to partner with, and looking for companies to talk to. We like I said, we're active in this area, looking for things to do. I would say two things to bear in mind. First is, this area is quite new and quite blue. The society is only been set up for 8 months. Like we said, for 20 years we discussed it, and we're only now moving into the digital twin space. Don't try to think so high level. Some of the issues that we have in manufacturing are quite simple, and probably with the technology and with the ideas, they're probably quite easy to solve, like motors overheating, or like not optimized parts, or excess energy. So there is the big problems, there's the AI, there's all, but I think there is some simple stuff which could probably get you as a startup into the business, getting some revenue going. So don't always try to solve the world. Think of also the small machine operators who are putting yellow caps on blue bottles, and they want to figure out how many bottles they need and how many caps they need. The second area is, I think Leo said it, humans can't see second order or third order relationships. So if you come with that sort of insight, and again, it's nothing you wouldn't have learned in university or college, those sort of insights put into a computer, put into an AI program, can revolutionize production, can revolutionize. So please think big, think future, think digital, but also don't forget, some of the answers are quite simple.
Thank you, Rav. Frankly, I think we lost our audience. It looks like they just killed the table, but for the record, anyway, most of the people are looking at it as a after fact. So just a summary remark, and I'll say thank you.
Sounds good. For the recording, absolutely. So I completely agree. There's no way for anyone to solve this alone, right? And the more we kind of go into this and the field, the importance of collaboration between new kind of scale-up startups as well as existing organizations and consortiums, right? But then kind of creating an ecosystem becomes more and more important. We need to replicate the ideas of digital twins and the connectivity within the way we actually develop the digital twin, and then share insights on a very close basis. I think that's absolutely right. I think that just from my perspective, where these use cases or the concepts or the key concepts of what digital twin will eventually look like are really forged in the daily active work with the customers, right? So it is really how Colgate or Procter & Gamble or Coca-Cola or any of our customers or any other large organizations, how they will do it and adopt the technology is what it will eventually look like. And obviously we can aggregate and generalize from there. And that is the work that we're doing, right? And other startups are doing. And if you are a startup, this is what you're signing up for. It's the grind of the business case, use case, providing actual value. And then of course you inform your direction by what the definitions are that come from other spaces as well. So that's kind of my take on it.
Good. Artem, Richard, Rav, Colin, I really appreciate your time. Thank you for the effort. It's hard time right now. No Thanksgiving, end of the year, still you found the time to participate. We really appreciate it, and it was a pleasure having this table. I don't know about the audience. I certainly learned a lot, so I'm good.
All right. Thank you very much, Leo.
Thank you, Paul.
Thank you, Leo. Thank you.
Thank you, Leo. Thank you, guys. That was also for me, learned a lot, and I'll be reaching out to Artem especially. I need to learn about machine health and what you guys are doing. I've been on Google secretly. Looks like we got a lot of stuff to talk about.
Very nice. I'll reach out to everyone as well. Let's see.
Colin, I'll talk to
And
you
if I
later
want a jet
today.
engine, Colin, I'm on the way.
Richard, Rav, you have to join the consortium because Richard promised that if Schneider will join, he will give another
Yeah.
free year to the startups.
Oh, I will join. I heard the discount, Richard, Colin. What was the discount? It was like a $5 or something, right? $5 a year. I heard. I'm there.
Okay.
I'm there.
Okay.
Thanks a
Okay,
lot,
folks.
guys.
Take care. Bye.
All right, thank you.
Bye-bye.